Capacitors connected in series. Now we have capacitor with capacitance C1, capacitance C2, and all the way up to Ci connected in series, and I'm calling the potential difference between the plates delta V1 for capacitor 1, delta V2 for capacitor 2, etc. And the whole thing is connected to a battery via a switch. So for I is equal to 2, I would have C1 and C2 only. So what would happen when the switch is closed? You will see that the positive terminal of the battery will call electrons towards this terminal. So what will happen is that the mobile electrons in the connection between the plate of C1, one of the plates of C1, and the battery will have electrons transferred towards the positive terminal of the battery. This will create lack of electrons on this terminal, and therefore it will create a charge Q1 build up. And at the same time, because this is going to create an electric field in between the two plates, so what we will see is that this will be at a positive potential. Therefore, electrons will have to travel towards the other plate of capacitor C1, and therefore we will see that there will be a charge plus Q1 and minus Q1 build up at equilibrium. The free electrons move to the right plate of C1 in order to have a balance in the system. So what about C2? Now we have charges that are being transferred from one plate of C2 towards C1, that those are electrons, and therefore there will be a charge Q2 building up on one of the plates, and this will create an electric field in this direction. Therefore, electrons will feel a force towards the other plate of C2, and there will be electrons that are supplied by the negative terminal of the battery towards C2. So remember, I'm talking about I equals 2 case, C1 and C2. So what happens here when the capacitors are connected in series? They have the same charge accumulated. Why is that? Because the charge that accumulates on C1 minus Q1 must be equal to plus Q2, because these charges are provided by electrons that got transferred from one plate of C2 towards C1, and therefore we will see that the condition that has to be satisfied in the connection in series is that they have the same charge stored. Q1 equals Q2 equals Q. And at the same time, the potential differences delta V1, delta V2, etc. should add up to the battery voltage in order to have the equilibrium situation. Okay, so what does that imply? If I write the total potential delta V, the battery potential is equal to delta V1 plus delta V2, and I also call the equivalent capacitance the charge stored Q divided by the potential difference delta V. This will be equal to the charge stored on any one of the capacitors Q divided by the total potential delta V1 plus delta V2. Now if I write 1 over C equivalent, this is going to be equal to delta V1 over Q plus delta V2 over Q. And I know that what I'm calling capacitance, the capacity to store charge, is Q divided by delta V. So this is basically 1 over the capacitance C1 plus 1 over the capacitance C2. All right. So what does that tell me? The equivalent capacitance of capacitors connected in series for two capacitors was 1 over C equivalent equals 1 over C1 plus 1 over C2. For I not equal to 2, I would have 1 over C equivalent is equal to sum over I, the capacitance index, 1 over Ci. So the capacitors, reciprocals of the capacitances will add up to give me the reciprocal of the equivalent capacitance. So for two capacitors in series, 1 over C1 plus 1 over C2 is C2 plus C1 over C1 C2, and if you take to the power minus 1, you see that the equivalent capacitance is the product of the capacitances C1 C2 divided by the sum C1 plus C2. So this is how I calculate the equivalent capacitance for two capacitors connected in series. Now what happens here is, as you can see, for example, if the two capacitances are the same, C square over 2C, the equivalent capacitance would be C over 2. So what I observe is that the equivalent capacitance is smaller than the individual capacitances. So this is an important result. It's going to be smaller than the individual capacitances. In the parallel connection, the capacitances would add up. Equivalent capacitances would be larger than any one of the individual capacitances. Okay, so what have we done here? When we connect capacitors in series, what happens is that the charge that builds up on each one of the capacitors is equal. Q1 equals Q2 equals all the way up to Qi equals Q, and their potential differences, delta V1, delta V2, all the way up to delta Vi, should add up to delta V. Okay, the potential of the battery, the potential difference between the terminals of the battery. And this equation tells me that the equivalent capacitance, the charge stored divided by the total potential delta V, is equal to Q over delta V1 plus delta V2, which tells me 1 over C equivalent is sum over I 1 over Ci. And for two capacitors connected in series, the equivalent capacitance is product of the capacitances divided by the sum of the capacitances, and the equivalent capacitance is smaller than the individual capacitances.